Recording this. So, good afternoon, everyone. My name is Anshul Mishra. I'm a third year computer engineering student from the Army Institute of Technology, Pune. We are representing the team God's Plan. My other two teammates are Arsh Tiwari and Abhinav Sharma. They are my batchmates, same branch, same everything. So, we have created this project as an explainer to be submitted in the OOSC 4.0 hackathon going on in Triple IT Allahabad right now. So our challenge statement is the first challenge statement, which was design an AI-powered system that continuously monitors geopolitical and logistical risk, models disruption scenarios and their economic impact, and so on and so forth. So yeah, let's dive into our project. And I'll be reading from a transcript. I hope that's not an issue. So just to put some facts on the table, and I suppose that was given in the problem statement itself, India imports roughly 85% of its crude oil requirements. A staggering proportion of these come from the Strait of Hormuz, Bab al Mandab Strait, and Red Sea. Both of them are high risk zones. So we have built the project council. Let's dive straight into the features. Open dashboard. Let's wait for the map to load up. I think I had the map loaded up. Yeah, there it is. So basically, we've only picked 6 major routes from which India receives oil. You can see international north-south transport corridor, Strait of Hormuz, Strait of Malacca, the Chennai-Vladivostok maritime corridor, and the Cape of Good Hope. And these 6 routes cover more or less 95% of the oil that we receive. There are some other routes, I think the Panama Canal, from which we can receive oil from the Americas. But adding these things will be dead weight. They'll just increase our code overweight. So we haven't done that, at least for the prototype. If we are selected and the judges ask us to do these things, then we'll be happy to implement that as well. So in the illustrative directions in the problem statement, the phase 1 was the geopolitical risk intelligence agent that has to basically assess all the routes and give out an empirical, what you could say, a risk factor, so that the dashboard can just show the. Actually, let me just show you what we're talking about. So you can see for the Strait of Hormuz, the risk factor that our risk agent has calculated is 40%. Oil is flowing, so everything here is zero. Supply drop, estimated price spike, everything is zero because obviously the oil is flowing. So no bad impacts there, which was, now let's move to phase 2, which was the disruption scenario modeler that stimulates events such as Hormuz closure or Red Sea suspension and their cascading impact on the refining prices and GDP. For that, what we have actually done is, currently how our risk agent works is, we are using a API by the name of FinFlight. So FinFlight basically gives you all the current news in a JSON format. We are using the Gemini API to read all the news and then calculate a risk factor. And on the basis of that, we are giving out the score for each route in phase 1. Once that is done, we are using that score as well as the data from PPAC. Let me just show you my data folder. We are using data from these are Excel files, so you probably won't be seeing them in a good manner. But data PPAC is basically a government website which shows you all the oil being imported from what countries it's being imported, the routes it travels by, whether the oil is LPG, naphthalene. There are upwards to 27 oil products in that list. And another thing we are using here is UN Comtrade supply data. This is maintained by the UN. The earlier one data point we talked about, that was being maintained by the government of India. And this UN data set basically contains the same thing: month in which we supply oil, the year, the countries between which the trade is happening, etc., etc. So if we use the scores that we get from phase 1 and the data that we have here, static data, and we use that to basically run our disruption scenario modeler, that if in cases route were to be blocked, what would be its impact on GDP and price spike, etc. So the thing is, we have artificially blocked the Red Sea route here for illustrative purposes. Our risk agent in phase one, the first thing, the geopolitical risk intelligence agent, that hasn't actually blocked the Red Sea because that is real, that works on real data. And in the real world, Red Sea isn't currently being blocked, but we have just artificially blocked it here so that we can show you what our model is capable of doing, what our app is capable of doing in case a route is blocked. So you see here, this is blocked. There is, then you can see the net barrel gap, the amount of barrels that we were receiving into India from this route. If this route were to be blocked, this would be the net barrel gap that we would be experiencing. Estimated price spike, oil prices would spike by 51.52%. Economic impact, supply drop, net barrel gap, replacement time, 32 days. This is basically calculated by, we are using the SciPy library. It's basically linear math. So not to get too much into the details, but it calculates the amount of time it would take for alternative supply routes to reach India using linear math. And since we have all the data for all the routes in the data folder anyway, so but this is real data, by the way. So now let's move on. Our fourth phase of the project was a strategic reserve optimization agent. Models optimal reserve drawdown schedules against the supply gap for forecasts. Here's the thing. We haven't actually been able to implement that in the, let me just show you, in the prototype itself. We have implemented this in the backend. Let me just wait for it to open. You'll see in the networks tab that we actually do receive a full 32-day plan from, why is this not, just wait a second. You'll see in the network tab that we do actually receive a full 32-day plan to how to release the oil, day 5, day 6, upwards to day 32, but we just haven't been able to implement that into the front end for the time being. Now, moving to phase 5, that was a supply chain digital twin, a geospatial simulation of the energy network enabling continuous what-if analysis. So here's the what-if scenario. You can basically just type in anything you want. There's an LLM doing all the work behind that. So that would extract the meaningful information that you need to run an actual scenario. I don't think this is working right now either. Malacca Strait blocked. Yeah, last time I checked, this wasn't working right now. So you can see, since this is artificial data, so this might come off a bit tacky, because when we earlier ran the model, the Red Sea was actually fine. So anyway, please excuse that. And you can see the full corridor breakdown for each route. Red Sea, as I've already earlier mentioned multiple times, we've artificially inflated it to 85% for illustrative purposes. So you can see all the impact, and all other routes are fine. So there is nothing to show there. They're operating at 100% capacity with zero supply deficit. And I think that's it. There are some improvements that we can make. Obviously, the most major improvement we would be making if we're selected, or just that we have the project, would be implementing phase 5, implementing the geospatial twin so that we can implement scenarios. User can input scenarios, and then we can show that here on the map and run an analysis on the price impact and everything. Other thing we can do is, we are already getting a full 32-day plan. Not like for that route it's 32, or otherwise if some other route were to be blocked, it would be some other number. The number isn't important. We are getting a full 32, 28, whatever day plan, and but we aren't able to display that on the front end as of right now. So we would be implementing that. And the third improvement we'll probably be making is, if we're able to get live PPAC and UN country data rather than static Excel files that we are using right now, that would be nice. So I think that's all. Yeah, I finished it from my end. Thank you for listening.